Welcome to ADF Insider. My name is Frank Nymphius and I'm from the Oracle JDeveloper and ADF Product Management team. In this session, I talk about ADF Region Interaction, which is an overview of the capabilities that the ADF framework provides for developers to establish communication between two different areas on the screen, hosting a bounded task flow. A region is an independent visual area on an ADF Faces view, where the ADF Faces view can be a page or a page fragment. We know about two different flavors of regions, the static region and a dynamic region. The dynamic region gets the bounded task flow reference from a managed bean, which also means that the bounded task flow can be changed so that different task flows show in one and the same ADF region, or in other words, in the same area on a screen. The static region has a string reference to the bounded task flow and always shows the same bounded task flow when the view is loaded and rendered. Dynamic regions are heavily used in the UI shell layout pattern. The UI shell, which also is used by Oracle applications, provides you with a template that allows you to set up different regions within one view that gives you the real desktop experience when application users work within your application. So based on the context the user is in, you might show different bounded task flow as part of a region, so that you have a highly dynamic application that you build with Oracle ADF. And a region always exposes a bounded task flow that is built with page fragments. And as you can see, the bounded task flow always starts with a default activity. Now that means as soon as the region loads, the default activity is displayed or executed if it's a non-visual activity. In this case, the default activity is a locking page, so it's a default view page that is displayed when the bounded task flow is refreshed. The important thing to remember when we talk about ADF region interaction is that once a bounded task flow is started, the options that you have is to have it rereading the input parameters, is to restart the bounded task flow therein, which also means it always starts with the default activity, which not necessarily is what you always want. And this is all about region interaction. Now, what is the use case that allows me to communicate within my region, and is it good to refresh the bounded task flow contained in the region, or do I need to find a way to communicate to the current view displayed by the bounded task flow? So that's all what region interaction and communication is about, and what this session is about. So let's first have a look in the ingredients list of what a region is. First of all, a region always uses a surrounding tag, and this surrounding tag is the ADF region tag. The ADF Faces region tag has a reference to a region model, and the region model, which comes from Trinidad, tells the region about the view to display and also feeds back to the region tag like about navigation that happens within the ADF region. In the Oracle ADF case, the region model actually is exposed by a bounded task flow reference that we configure in the ADF binding layer of the parent view. A bounded task flow is a series of navigational steps between page fragments, which we then can expose as a part of a screen through ADF region tags. Optionally, if you have a dynamic region, we can use a managed bean, or actually we will use a managed bean to swap out the content of the ADF region. So a managed bean has a method that is referenced by the task flow binding that is created once we drag and drop a dynamic region, and this reference can return different bounded task flow document references based on the condition that the managed bean state is in, and this way we can have one region showing different bounded task flows conditionally on what the user is currently doing. This also is what UI shell is all about. Then there is a page definition file, and this page definition file is the binding container of the parent view. So that's the view where we drag and drop the region into, or the bounded task flow as a region into. And this page definition file contains in its executable section a task flow binding that references the bounded task flow to display as the dynamic content of the region. And then we have page fragments. Page fragments is what you would have to use to represent views in the region, so that users can work actually with the bounded task flow. So it must have a view, and this view is of type page fragments. So page fragments are incomplete Java Server Faces documents, and similar like JSP includes, just more dynamic, more agile. They are injected or provided at runtime in this area of the page which is represented by the ADF region. So how do you create an ADF region? As simple as drag and drop. So you select a bounded task flow in the application navigator, and then you drag the bounded task flow onto a view. A pop-up dialog opens that asks you to create a region or dynamic region. If you happen to create a dynamic region before, then two more options show in the pop-up menu, which is to create links so that you can switch between different bounded task flows exposed in a region. So it's all declarative and it's all there. Once you dragged a bounded task flow as a region, what will happen is that in the executable section of the page definition file, the binding container of the parent view, there is a new task flow binding created, and the task flow binding is of type region binding, which in fact is another binding container. It's not that at runtime you necessarily need to know about this relationship, but it's good to know that the parent binding container at runtime will look at what are my dependent binding containers that I need to activate and reference at runtime, so that the content of this binding container also becomes available to the Java programmer or the ADF programmer, of course. And then you can see from the screenshot that there are a series of properties to set and some parameters to work with, and they are all listed here. So starting with the task flow ID, the task flow ID just gives us a reference to the task flow definition, and this task flow definition either is a static string starting from the web-inf directory of the location where the bounded task flow that you want to show in the ADF region is located in, or it's a reference to a managed bean. If it's a reference in the managed bean, make sure that the scope of the managed bean is broader than request, because otherwise every work within your application that of course will lead to a client sending a request to the server will reset the managed bean, which is not what you want, especially if you want to swap out the task flow, if you change the task flow. So make sure that this task flow ID, the managed bean that you use for that, is at least in view scope, which is not by default, but now that you know, you can have a look for it. Then the parameter map. Bounded task flows may require input parameters, so these can be provided either through named value pairs in the parameter section or through a hash map. Now the hash map reference is an expression language string pointing to a memory scope or to a managed bean, where for best practice reason I usually would prefer to use a managed bean, because that way it allows you to document what the hash map is for, which is kind of difficult to do if the hash map sits in the memory scope. The hash map is good to use especially for dynamic regions, where you swap out the region, where you swap out the bounded task flow, because different task flows might require different sets of key value pairs as the input parameter, which is a lot easier to do with a parameter map than just by anticipating what the parameter names would be. If of course the bounded task flows that you use have the same names, then you can use named key value pairs in the parameter section as well. The refresh option can be set to default or if needed. If set to if needed, then the bounded task flow within the region will be refreshed whenever an input parameter, a named input parameter value has changed. So if I look for the row key like in this screenshot, and the row key value changes, then on a partial refresh of the region, the bounded task flow will start again on the default activity. The other option is to set it to default, in which case it looks for the refresh condition. The refresh condition is a expression language string pointing to a managed bean or a memory scope that returns true or false. And based on this condition, again, the region refreshes in response to a partial refresh issued on the ADF Faces region tag. Activation, this property determines when the bounded task flow gets initialized. By default, this setting is set to deferred, not to immediate as shown here. Deferred means that if a region is contained in a panel tab and the tab that the region is in is not displayed immediately, then the bounded task flow is not getting initialized. As soon as the user displays the tab that contains the bounded task flow, then the bounded task flow will be initialized and the default activity will be executed. If you set this to immediate, then no matter what, even if the bounded task flow is not visible, it will be instantiated and will be present. Then there is another property called active. If activation is conditional, which is a third option that you have, so beside of immediate and deferred, you can have a conditional task flow activation, then you need to provide expression language returning true or false at runtime to determine when exactly you want the task flow to be initialized. Once a task flow is initialized, even if it's on a panel tab, if you switch to another tab, this task flow is not closed, it's not exited, it still sits there. Yeah, so this is just for the initial loading of the bounded task flow. The region input parameters, even when you specify them through the property inspector, will be created in the structure window as well. So it's entry under the task flow binding reference. It has an ID, it has a value reference, and you can also specify what it should be evaluated. The screenshot actually shows the default settings for this input parameter. So this is all about regions. Now we have a good understanding that regions expose bounded task flows and that you can have multiple regions on a page, like in a dashboard, that now you want to set up so that they appear as a single application and just provide this desktop experience here. And this is where we talk about ADF Region Interaction. Now, what are my options to talk to different areas on the screen? What we want to do, and there are different architectural decisions to do here. First of all, when we talk about ADF Region Interaction, are we talking about establishing communication without breaking ADF region encapsulation, which means that bounded task flows as they are, if I want to reuse them, I cannot make a lot of assumption about the context they're running in. I cannot make an assumption about the data control sharing. I cannot make assumption about memory scope attributes that are available or managed bean that are available. Bounded task flow that you want to reuse typically communicate with the outside world through input parameters and return values. So if reuse is a goal, then obviously even in my decision for which interaction pattern to choose, I cannot use anything that makes assumptions, so I have to use something that avoids tight coupling and just uses the input parameters. If I'm using bounded task flows and ADF regions just within one project to split up the work in a team, for example, which is pretty neat, because especially if you have a large team spread across the world, you might just identify modules in your application and just build them as a bounded task flow and then bring them together, assemble the application later on. In this case, you might be okay with the tight coupling, where you can say, okay, this is the context we agreed in. We know that this managed bean is there, or we know that this data control is there, and that this is the name of the data control. And we may not have a plan to reuse what we build, in which case there are a different choice of region interaction pattern available to me. The basic interactions are parent view to ADF region, so where the view that hosts the region talks into the region. Then we have an ADF region talking to the parent view, just reporting back to the parent view. And then we have, of course, independent regions on the page talking to each other. And of course, there is technology for that, and this is what we're introducing now. So this is the overall choice, and you see that I marked some of them with a red star, identifying those that clearly make assumption about the context they're running in. When I say it breaks encapsulation, then what I'm saying is that you either need to have good memory, good documentation, or no plans to reuse the bounded task flow that you want to expose in the region. However, these are all valid technologies to implement the three areas of region communication. To start with the parent view to ADF region, we have contextual events. There's a separate recording, and I have a link for this for you to look at what contextual events are in detail and how to build them. In this session here, I just give you a brief overview. Then there is a method on the ADF region instance. So there's a rich region instance that you create in a managed bean by creating a JSF component binding using the binding property on the ADF faces region to a managed bean. And this has a method called QActionEvent, which allows me to call into a bounded task flow that is exposed in a region. So I can say, okay, if the current view can navigate to view 2 or view 3, I can call into it and tell it where I want to navigate without fully refreshing the bounded task flow. Then of course I can use input parameters, which would require, as we learned before, to refresh the whole bounded task flow within. We can use a shared ADF data control. And shared ADF data control is like a session managed bean that just spans all the regions that you have. The only difference is that the data control actually provides data. It provides the business model, and it can take care for synchronizing different views, especially if you use ADF Business Controller, which has an active data model, but also with EGB, which might have nested objects. So you can use data controls and share data controls between regions to synchronize data views. And then we have drag and drop. As we know that ADF Faces provides a drag and drop framework, I could have a drag source and a drop target in different regions. It just, and this is why it has the asterisk, it's just making an assumption that either the drag or the drop exists on the different regions. For the ADF region to parent view communication, again I do have contextual events, which basically works in all situations. I do have a region navigation listener, again, which is exposed on the rich region tag. The rich region instance of the ADF Faces region tag has a region navigation listener property that I can set to listen for the navigation in the region, to listen for what's the current view, and if the view is null, then obviously someone exited the bounded task flow. There's another tag called the parent action that allows me to declaratively within the process and the flow of my region to call a navigation case or control case, as it's called in ADF task flow, in the parent view and navigate off the parent view. So that could be like if I fill in an order shipment, which is part of a bounded task flow in the region, once I hit the final page, I may want to navigate the full view back to some sort of overview page that allows people to print the order. And I can do this declaratively with the parent action. Again, I can use the shared data control or drag and drop. The ADF region to region communication, where I have two independent regions on a page, have three ways to communicate. One is contextual events, which is powerful and recommended. The other is to use a shared data control and to use drag and drop. So let's get started. I mentioned that the contextual events framework that we can use with an ADF to communicate between regions is the most powerful, because first of all it can be used in three scenarios: region to region, parent to region, and region to parent, and it's kind of considered to be a silver bullet because it works in all three situations. The contextual events is a framework within ADF, and it requires the binding layer to be available on all ends, so it must be available in the message receiving part and in the message producing part, and it's using a mapping that allows us to listen for either ADF events. There are ADF binding events like value change events, and also region change events or range change events in the binding layer, but then also to listen for Java server faces and ADF faces events for the cases where the UI component that is producing the event that we are interested in propagating a message with is not bound to ADF. Events are typically delivered to the local container first, and events are always delivered to those containers that are active to the point in time when the view is rendered. remember that I said that every ADF region uses a task flow binding configured in the parent view. And this way, when the view, the whole page, the browser page, renders, at rendering time, we initialize all the reference binding containers, make them active. So this is when I talk about an active binding container. That means it's active to the time that the view renders and that the view is displayed. And those binding containers now can receive events or produce events. When the event is raised, then it's first published to the local container. So basically the container that maybe the button belongs to, or the input text field binding belongs to. If there's no mapping found for the event in this container, it bubbles up to the next parent container, and so on until it hits the root, which is the browser window, or the parent binding container. And then it just turns around and again goes back and delivers the message to all event handlers, possible event handlers, that just want to listen for the event but don't explicitly specify the producer name. So it's like in the tree, and this is why I have this icon on this page. We just broadcast the event to all of the leaves and all of the branches of active binding containers. And then if there's an interest to handle the event, then this can be done in Java. As mentioned, there's a full recording on contextual events, so I'm not going into further details within this session because there's so much more to cover in this session. There's a recording about building contextual events with Oracle ADF. Here's the link. You either go straight to it or just use Google and type in Oracle ADF Inside and it will bring you to the main page, and then you can have a look at contextual events. For this session, I just want to show you a demo of what contextual events can do for you and how it works. The basic sense on contextual events is that contextual events don't require you to restart the bounded task flow. So contextual events work within the current view that you see without restarting the bounded task flow. So it's a very flexible and very dynamic and very powerful way of communicating to the region without changing the current state and the current status of the region. So let's have a look. In this sample we have 4 ADF regions, 1, 2, 3, 4. Each of the region is referenced in the same bounded task flow, which means that we have 4 instances of a bounded task flow exposed in an ADF region. The department name field is bound to a contextual event that is fired through the page definition file, and then the submit custom payload just reads what the current value of the location ID is and sends it to the bounded task flow. So first of all, let's change the administration to administrations. Submit the payload. This now sends the contextual event and updates 2 panel boxes in here. And the update of the panel box doesn't require any bounded task flow refresh. It just sends it to the active binding container, which is actually linked from the current view that we see exposed in the ADF region. So if I click Submit Custom Payload, then as mentioned it reads the location ID and sends this value to the panel boxes. If I combine the two, so if I change administration back to administration as a singular and then change this as well, press custom payload. Now what happens now is I'm submitting the form, which means that the value change listener will fire, plus my custom payload reads the new location ID, and then it will update all of the 4 panel boxes as one. So you see that I can have multiple events sent and broadcast to different regions and then have the region responding to it. The way that the region responds to it is through a method binding that is defined on the region or the view fragments page definition file. Again, the whole demo is explained in a separate ADF Insider tutorial that you may want to have a look at. So let's go use case by use case. First, the communication between parents to region. And here the first example to give is to communicate between a parent view and an embedded region through its input parameters, so the bounded task flow's input parameters exposed in the ADF region. For this, we need to think about when our region is actually getting refreshed, which means that the bounded task flow gets reinitialized and because of that rereads its input parameters. First of all, of course, the initial rendering. So when the region initially renders, which could be upon loading of the page, if the refresh is set to immediate, or deferred when it's exposed on a panel tab, so the user navigates to the tab. So the first time the region references the bounded task flow, it will actually read the input parameters. In the case of a dynamic ADF region, whenever the bounded task flow referenced by the dynamic region is changed, then of course the input parameters are reread again, which gives us the ability to pass in new information. To refresh a region, we have to put a partial page refresh command onto the ADF region. So we have to make sure that the region tag itself refreshes so that the area on the screen that contains the bounded task flow refreshes. And here we already learned that there are two properties to set on the ADF region binding, which is the refresh condition or the refresh options, that would allow us to either refresh the bounded task flow in response to a parameter change, in which case the refresh option would be set to if needed, or just have some external condition determining whether or not the bounded task flow exposed in an ADF region refreshes and rereads the input parameters, in which case the refresh option is set to default and the refresh condition will be set to true or false with an expression language string. And there's another, which I call brute force option to refresh a region and make the bounded task flow reinstantiate, which is to call refresh as a method on the rich region instance. As mentioned, the rich region instance is something that you create by creating a Java surface component binding of the AF region text property binding. So the binding property it has, if you reference a managed bean from that, it creates a setter and getter for this rich region, and then you get a reference to this rich region instance and you call refresh on it. So that could be in response to a value change, this could be in response to a selection change, this could be in response to a button press. You just get an access to the rich region instance and call refresh as a method on it. And the refresh takes one single argument, which is the faces context, which you know how to get. And that will also then refresh the region, and the region will restart the bounded task flow, and the bounded task flow will reread the input parameters. That's a way where we can pass in information. I have an example for this, which is showing a master detail behavior, in which case an input parameter represents the currently selected row or data in the parent view that then mirrors to the detail view, so that when the detail view, the region is refreshed, the detailed data is shown. This sample shows a master detail behavior between a departments table contained in the parent view and an employees table contained in an ADF region. When I select a new row in the departments table, then this row change will be passed through the ADF region binding to the contained regions and will trigger the region to refresh and show the correct detail data, as we can see here. The collections between the department and the employee are independent. That means there is no contained master detail correlation within the model, though I'm using ADF Business Components, but I made sure that the view objects are not dependent on each other, which means that this part here, the region, could be stored away in an ADF library and reused in other application, because all that it lives from is from a change of the input parameter and the refresh of the region. In the design time, I do have the departments table here in the parent view, and then I have a region, which you can tell because of this green area here. Whenever the region doesn't have a view activity as the default activity defined, then this green area is indicating that this is a non-visual activity that it starts with. If I switch to the Bindings tab, then I can see that in the parent view I do have a Departments View 1 collection exposed as a tree binding, so to populate the departments table. But I also created an attribute binding so that whenever the user selects into the table, I have a synchronization on the binding layer side with the current row, and then this allows me to easily, in expression language, access the department ID from the current selected row. In the executable section, I do have a task flow binding, and this task flow binding references my bounded task flow that I want to show as a detail on my parent view, but that I also want to refresh whenever there's a row currency change here. If I select the task flow and then look here in the structure window, you see that there's a parameter defined which is called the row key, and if for this row key we look into the value, then we see it references the binding, the department's ID input value. So I'm passing the currently selected department ID as an argument to the ADF region, and then I use a partial page refresh to refresh the region. And because the region setting is to if needed, the input parameter change causes the bounded task flow contained in the region to rerun. And if we look at the task flow, then we see that the first activity, the default activity of the bounded task flow, is a method activity, and that method activity takes an input parameter, which is the department ID, which I'm passing in as an input parameter to the bounded task flow, and then re-executes the first query, which is browse employees. So if I look on the task flow, then what I see is that this task flow has an input parameter defined as row key, and that this row key value then gets passed to the bounded task flow page flow scope key attribute, which is a memory attribute, which then is referenced as an argument in the method binding used by this method call activity. And this is then how we can pass the value into that region, and whenever the input parameter changes on the ADF region, the bounded task flow is re-executed because of the ADF region refresh, and then it rereads the input parameter, passes this to the method call activity. The method call activity queries the employees data, and we see a full master detail behavior, though it's decoupled. This also is a very good example that you can use with any kind of ADF models, not only ADF business components. You can use the same with web services. Whenever there's a region that contains a web service that queries data, you can just pass in the input parameter value and create a master detail behavior between two different views that contain services. One of the ADF region interaction scenarios that I flagged with a red star is the drag and drop functionality that you can use to pass data between a parent view to a region, or even to pass data between two regions, or from a region to the parent, because it works in all three scenarios. Now, drag and drop is a framework that is provided by ADF Faces, and drag and drop as the gesture works on the client side. And in JavaScript, which is used on the client side to perform the drag and drop operation, there is no boundary, there's no ADF region, there's no notion of an ADF region. So what appears to be independent at the design time, in that the region is an isolated environment, doesn't appear isolated at runtime. Now this allows developers to use drag and drop to pass information from the parent view into the view currently displayed on an ADF region. To set up drag and drop with ADF Faces, you use a tag to identify a component like a table to become the drag source, and then when you drag and drop, the target of the drop operation is another ADF Faces component that you put a drop tag on. The payload that is passed between the drag source and the drop target is passed on the server side. So what the client does is it just notifies the server about drag and drop to happen, and then on the server side, in a managed bean listener, developers get access to what's the actual content that gets dragged and dropped from the parent view to the region, or from the region to the region, or from the region back to the parent view. So we can use that, but keep in mind, if you follow this approach, that reuse might be very limited because of the assumption you make about the drag and drop. Example use cases for this would be a shopping cart. So if I have an ordering website like Amazon or any other online business site, then I might not be so much interested in having a good portion of reuse for the bounded task flow I'm building. I might be more interested in the transactional boundaries that the bounded task flow represents. So in the case of a shopping cart, I don't want to have the shopping cart to be committed only because users at the same time change their preference profile on the website. So for this, the shopping cart should be isolated, running its own transaction, which I can easily do with the bounded task flow. And then on my final shopping homepage, I just bring the two together. I have one region, or the parent view, representing the catalog, and I have the region exposing the bounded task flow, which is my shopping cart, handling all the shopping that the user does. Now I can use from the catalog a drag gesture and drag and drop a product to the shopping cart, and on the shopping cart I would then show the image of the product and ask the user to specify how many more items of this type they want to purchase. So for this I could use drag and drop, but just keep in mind it weakens the task flow encapsulation because you make assumptions. I make assumption that there is a drop target in the region, and I also make an assumption from a region perspective that there's a drag source somewhere out there that I know how to handle. But beside of that, it's a good way to do. It's not prohibited, so you can do that. It's just something you keep in mind, that this really breaks encapsulation. Its reusability is limited with this approach. Let's have a look at an example. This is the runtime view of this little sample, and what you see is a table on region 1 which displays departments, and then I have a table on region 2 that represents the employees. Now when I drag information from the departments table in this case and drop this on the employees table, then the drop event is handled in the region, and it's used to requery the table to show, in this case, the employees working in that department. So I can do the same now for department 60. I drop the event, requery happens, data is refetched, and then you see I have this master detail correlation working just by dragging the department value that I'm interested in querying the employees for into the employees table. Looking at the design time view, I have my region 1 here and the region 2 there. You see that the default activities in both cases is a view activity, in which case it's indicated through the region shadows that the default activity is a view. The table in the departments region has a drag source defined, and the table in the employees view has a drop target defined. So if I go here, you see here's a drag source defined, and this drag source just has an indication of actions to be copied, and a discriminant is set to departments. If you read into drag and drop, then you see that the discriminant makes sure that if you have different instances of drag and drop capabilities in your view, that you can identify a specific drag and drop, the drag source and the drop target, by a discriminant. So similar, when I go to the browse employees page, this also has a table, and this table has a drop target defined. If I select this, and then here what we see, the action again is the copy, and this has a reference to a managed bean to handle the drop. So whenever there's a drag and drop between the regions, then there's a drop event that is raised here in the managed bean, and here you see everything you can read in the web developer guide about drag and drop. I access the transferable through the drop event, which gives me access to the payload. Then there's a row key set class that I'm passing in, so the discriminator is department, so I get the right message out of it. And I just look it up, what is the department ID that's used, and then query the detail record in the query employees method. And this way I get drag and drop working so that you get the master detail impression, or if it's a shopping cart, you drag the product from the catalog into the shopping cart and then have the user filling in the form with more detailed information. Another option to pass information from the parent view into a region is the queue action event in region, which is a method exposed on the ADF region component, more specific on the rich region implementation class. The rich region allows you to peek into the executed bounded task flow to check the capabilities of the bounded task flow. And the capabilities are navigation cases that are defined for the current view that you can see exposed in the ADF region. And what are your navigation options? So if you're on a department table, your navigation option might be to go to the edit department or to browse employees based on that. And you can query these capabilities, and once you have an idea of what the options are, you can then queue one of these options and have the region continuing with the navigation without reloading the region or without re-instantiating the bounded task flow. You just keep on going. It doesn't require a refresh of the region at all. It just calls into the region, and then in the region the process will continue. So the region signature, or the queue action event in region signature, is shown here, and it requires an action expression which is just a string. Of course you can pass in method expressions into the region, and that would be executed in the context of the region. It's also identified as kind of an anti-pattern if you do that, because there's no notion of discovering the possible method activities. But again, if there's no idea that you have about reusing a bounded task flow, so you know exactly what's going on in the region, what are the bindings, or what are the managed bean that you can access from a method expression, then yes, in theory you can use that. But again, it will break encapsulation, which means that the region or the bounded task flow will no longer be reusable. But you know, in the end, what really matters is the use case you're trying to implement and the application you're going to build. And if reuse is not on your agenda, then you might be good to use method expressions as well. But by default, we will just look into passing in the string that identifies the controller case. Well, the navigation that you're continuing with could be that it opens up a dialog, in which case you might want to reference a managed bean which represents the launch listener method expression or the return listener method expression, so that you can respond to the starting of the dialog or to the return from the dialog. You could set use window in this case, again also setting the width and the height, which is required by the dialog to identify its width and its height when it pops up. Then the last argument it expects is the face ID to execute in. In most of the cases, and now I'm in the second box here, in most of the cases we're not launching anything that's in the dialog when we call from a parent into a region, because after all it's an ADF region interaction pattern, so we want to see the region changing and not just popping up or pop up. In this case, the arguments that you pass is just a method expression that, as again mentioned, just could be a string for the control flow. Then you pass null for the method expressions identifying the launch listener and the return listener. The width and the height can be passed in as 0, and then the phase in which you mostly want this to be executed is invoke application. So this simplified call is what I think you would use in most of the cases, if not in all of the cases that your application development will be concerned with. To determine region capabilities, there are two ways to do that. One is expression language, the other one is to use Java. and everything you can express with expression language and access with expression language, keep that in mind, is also what you can access with Java, because expression language is just under the shelves using Java. So expression language is nothing else than just a wrapper put around a Java method API call. So in this case we have the bindings reference, of course. Then there's a region ID, so you wouldn't use that with a square bracket. It's just to indicate that the region ID is what changes. It's a task flow binding ID that you're referencing here. This has a method exposed called the region model, and this has a method exposed capabilities, get capabilities, which returns a hash map. So you can check for a specific outcome here. So if there is a navigation control outcome for the current view that you see in the region, then the return of that string will be true, otherwise it will be false. You can also check for any other outcome. You can also just use the expression language to get the full list of controls that you have available. Maybe use EL in a Java managed bean to reference the list of possible outcomes. Here's an example how you could use that expression language string from Java. You see that I created a value expression, and then this value expression referenced the same binding string. It will go through the EL context. Typical Java surfaces programming, so no rocket science here. I resolve the value expression. This returns true or false as a Boolean value, and then I continue with whatever I needed to do, maybe hiding or showing a button to follow that navigation case. I could have the same shorter in that I use the rich region reference. Again, this is the Java surfaces component reference I can get by using the binding property on the ADF region to point to a managed bean, call get region model, and then call get capabilities, and you see this returns a set of strings, and then I can check on this set of strings, I can check if a specific outcome is contained there, or which is another option, to populate select one choice with the options that you find, and then have the user deciding which of the possible control flow cases to follow. Let's have a look at the little example here. This sample shows how the queue action event in region works. In the parent view, we have a tree control that lists all the locations that we have in the HR sample schema. On the same parent view, we do have two buttons, one to navigate the region to the departments view, and one to navigate the region view to the employees view. Because the departments view is what we currently see, the departments button is disabled, which we do through a check to capabilities. Now, what are my options here? If my option is only just to go to the employees, then just the employee button will be enabled. So selecting South San Francisco shows all the departments that belong to San Francisco, which is just shippings. If I click the employees button, then what happens is that we queue a navigation event in the region to display all the employees that belong to the location of San Francisco. And here's the list of employees. At design time, there are two things that need to happen. First of all, every selection of the tree node must set the current row, which is the default functionality in ADF, but also make sure that the ADF region is refreshed. So it's restarted, so it rereads the input parameter, which in fact is the location ID that we want to pass in as a parameter to the bounded task flow exposed in the region. Second, when a button is pressed, departments view or employees view, then through the checking of the capabilities, it must be ensured that the button is disabled, which view is currently displayed. So let's have a look at the departments button. So if we go to the property inspector and have a look here, then the disabled property points to bindings, the task flow definition, the region model, capabilities, and just checks if the capability, the navigation capability, is employees. And if that is true, then the button is disabled, because obviously we're already on the departments button. When the user selects a tree node, What we do then is we execute the default functionality of the ADF binding layer, which is to set the current node to become the selected node in the binding as well. But then at the end we call ADF region refresh, and remember that I mentioned that there are several ways to refresh a region actively, so the bounded task flow within is re-executed, and one is to call refresh on the region instance. So for this I created a region binding, so it's of type rich region, and it's using the binding property on the AF region. This allows me to refresh the region so that whenever I select a new node, I see that the region gets refreshed. To switch between the departments, I use an action listener on each of the buttons. So for instance, the employees button uses the switch to departments view. So it sets an internal outcome to departments, which is the navigation case in the bounded task flow, and then it calls a helper method, switch view, and all that this does is it defines the method expression as I showed on the slides, and passes the outcome string, which is a control flow, to the region, and then invokes it on the region. This is the bounded task flow. It starts with the default activity, which is always executed, which is departments executed with params. This executes the query for the departments view with the location ID passed in. The control flow case that we see here is employees or named employees. So once we press the button to navigate to employees, then the employee string is passed in with the queue action event in the region to the bounded task flow here, and then the task flow continues with this control flow. Employees execute with params, again reading the location ID, but this time it's not reading it from the input parameter, but now it's reading it from the page flow scope memory attribute where the input parameter is stored, so that permanently, for as long as I'm working within the bounded task flow, this parameter is available, so that I can always query the correct data for the current selected location. So let's have a look at the region to parent communication pattern. As mentioned, one pattern that always works is to use contextual events to call out from the region to the parent, but there is more. The parent action is a specific component tag that you find in the Oracle JDeveloper component palette, and this allows you to specify within the bounded task flow that is exposed in the region to specify a parent outcome that is first looked up when you navigate from a view to this activity. If it can find a control flow case defined on the parent bounded or unbounded task flow, depends on how deeply nested you are with the region, then it will navigate off the parent page. If it cannot find that, then as a fallback it will have its own outcome defined, which would allow you to have an alternative navigation route within the region itself. So the first thing it tries is to navigate off the parent view. If it cannot do that, because there is no control flow case defined, it will fall back to its own control flow, and if that isn't defined, then it will just stay where it is. It will not continue navigation. Of course, everything that you can invoke an expression language or that we have an activity for must come from somewhere. And in this case, it comes from the controller context, and there is a viewport context implementation class that allows you to get the current viewport. And once you have access to the current viewport, you can queue the parent action event directly in Java code. So that means that if you know that there is a control flow case on the parent view that you want to evoke programmatically, then you can do this from the embedded region. So let's have a look at an example. In this example, I do have a page that contains a region within, and in this region I can select one of the users or account owners and choose to edit the selected row. Now at the end, within my bounded task flow, I want to redirect the user to a summary page. So if the editing is successful, then I want to navigate off to a summary page that could also be an order summary. Yeah, so if you have a shopping cart represented in a region, and then once you finished your shopping, you want to navigate off to a summary page that eventually then allows you to confirm and to continue with the payment options. I'm selecting the Edit Select option, and then just change the mail to mymail.com. I press Submit, and this now attempts to navigate to the parent control flow for the summary page. If it fails, it would just go back to the previous region page that we've seen. And as you can see, it ends up in the summary page. So I'm calling the parent navigation flow for the navigation. The design time for this looks at, I always start with the default activity in the region, which is the employee's view. I select an employee and go to the edit page, and from the edit page I continue with a summary control flow to my parent call activity, which is this here. The parent call activity is not directly visible in the component palette. For this you have to go to the source elements, and on the source elements you navigate down, and here is the parent action. The parent action itself has properties. You see I have the parent outcome set to summary, which looks in the ADFC config file, because I don't have a deeply nested bounded task flow in the sample, for a navigation case called summary. If it cannot find it there, it goes back to the default activity, so going in circles. There's also a property called a root outcome. So just in case that the bounded task flow that is exposed in a region is a nested region, then maybe you don't want to navigate the parent view, but you want to navigate the complete site, the browser page, in which case you set the root outcome. On my ADF config file, I do have my departments view, which contains the region, and then if there is a navigation case called summary, it will go to the summary page. Now this is exactly what the control flow is that is called from the embedded region. So what you can see is that declaratively, and as I showed you on the slides as well in Java, you're able to call out of a region to the parent container, have the parent container navigating, or just have the root page navigating. Another interaction between the region and the parent is the use of the region navigation listener. The region navigation listener is configured on the AF region tag. It belongs to the region, and it has a property that allows you to specify a region navigation listener, which in fact is just a reference to a manage bean method that is invoked whenever there is navigation performed within the region, and then the parent container can respond to that. For example, I could define that whenever the current view ID in this region is null, that the parent view should navigate off to the next page, similar to what we could do with the parent action. There's one example that I have the URL here where this pattern is used, the region navigation listener, to pop up a bounded task flow in a light white pop-up window. Though since 11.1.1.3 we do have the option to use the external dialect framework for navigating to a bounded task flow that then opens up in a DHTML pop-up. This would require JSPX document in this bounded task flow, which not many customers like. They want to go consistent with only page fragments. So if they wanted to show a bounded task flow as a pop-up, maybe as in an implementation of their own list of value, what they could do, and this is what this link explains, they could have a bounded task flow in a region and put that into a pop-up window, and then to indicate the pop-up to close, they will just navigate to a return activity in the bounded task flow, in which case the region navigation listener will receive a null for the view ID. In this case, they know that they have to close the pop-up and replace the pop-up content with an empty region ID. Here is not the pop-up example, but another example that shows you how to use the region navigation listener and what that is good for. This is the slightly modification of the queue action event in region example. Instead of having only two buttons that allow me to switch the view of the bounded task flow exposed in a region between the department's view and the employee's view, and disabling one of the buttons based on the options that I have in terms of control flow navigation, in this case I use capabilities to query the current options for control flow cases and show them in a select one choice. In this case I do have a one control flow that goes directly from the all departments to the employee's view, plus I have two defined wildcard control flows that are also listed as capabilities, as options for me to navigate. And then I do have an execute button in the parent view, which allows me to call into the region and then navigate the region. Before I show you this option, let's navigate within the region directly, because this button sits in the region. It's part of the first view displayed by the bounded task flow. So when I navigate to the Go to Employees page, what will happen is that the region navigation listener that I defined on the region here will receive a notification about the navigation and then about the change in the display of the view ID, and see what happens with the select one choice. So I'm navigating within the region and the select one choice has changed. So now it shows Go All Departments as the first selection, and of course the wildcard control flows don't change. So now I can select the Go All Departments here and now trigger the navigation back to the department's view in the region by just queuing the action, and again see that the navigation picker changes. Now the default option is Go All Employees, and this default setting of a select one choice, this is controlled by the region navigation listener, because as you know, to set the default selection of a select one choice, either the model has to do it, or in my case a managed bean. At design time, the select one choice has the default value that looks at a view scope managed bean, and there is a current select option, current navigation option. If I go to the managed bean that is referenced by this, then what I can see is that this is a region navigation event that it receives, because this is configured as the navigation listener, and this navigation event then determines if the index of the view ID that I'm currently on has the employee in it. If so, then the current navigation option is called All Departments, and otherwise it's called All Employees. But the reason why the select one choice changes, this is just declarative partial refresh triggers that I configured between the region and the command button. So these are having partial triggers, so that whenever there's a change in a region, a partial trigger event will be sent to the select one choice to refresh itself. And a last view on the region, so if you go for navigation listener, here you see that the region navigation listener is specified to point to a managed bean, and this way whenever there is navigation within the region, it will inform the managed bean that sits in the parent scope of the sample. Another way to communicate between regions and parent views is to use a shared data control. The shared data control, which is the default setting on the bounded task flow, appears like a silver bullet, like the contextual events, but actually it has dependencies. And the dependency is that the data control that you have in the bounded task flow must match the data control that you use in the parent view, in that there need to be a dependency between the collections, because this is what the shared data control then is good for. If there is a change in the parent of a data control in a parent collection, then the data collection are refreshed by simply calling a partial page refresh to the region without having to re-execute the whole bounded task flow. So in this regard, it works almost like the contextual events, though it's not as independent and separate. All regions are configured as task flow bindings on the parent view's page definition file. This makes sure that all the associated bindings, so the binding containers that are referenced by the page fragment of the current view, is becoming active, is added to the parent binding container at runtime, so that all the data is synchronized and updated. If you share the data control instance, then there are two things you can do. One is what I already mentioned, the master detail behavior, where you have a dependent collections in the bounded task flow or in the parent task flow, and then you simply change the row currency of the parent and partially refresh the region, in which case then just the data is refreshed that you see. So it's not that the bounded task flow is refreshed. In many of the use cases that might be okay and sufficient, so you don't need to go for contextual events. But keep in mind, if reuse is your intention, then having this kind of dependency in mind, that people have to remember that a specific collection has to be chosen on the data control just to make this work, may make it difficult to store bounded task flows for reuse in different applications in an ADF library. Another example where a shared data control might be useful for is documented in a blog entry by Andreas Baranowski, in which he uses the data control as a storage that spans between regions or between the region and the parent view. Because if there is a caching mechanism on the business service, then through the data control you have access to this on both sides of the medal. So the parent view can access the data control, and there is on the binding context there's a find data control method that you can use to find the data control, get a hold of the data control, and then look up whatever data you want to look up, and you can do the same on the other side in the region. By default the sharing is enabled, but you better check, go to the task flow properties for the bounded task flow and see if the data control sharing really is enabled if it's selected. For the data control sharing, especially for this master detail behavior, there's no input parameter required. So you don't, because not necessarily the bounded task flow is re-executed. So, and since the master detail correlation is managed by the business service or by the data control representing the business service, there is no need for you to pass in actively an input parameter for the detail query. However, be aware of the dependency that you create, because if you have a dependency to a specific data control, to a specific collection, and even to a specific nesting within the collection, then that is something that limits a bit the reuse that you can do with that. But as mentioned in the beginning of this presentation, reuse not necessarily is what you want to follow just to use ADF regions. You may use ADF regions, as mentioned, to make it easier to develop in teams, or because you want to use the UI shell pattern or template just to get this kind of context sensitive displaying of the user interface that gives you more like a desktop experience. So let's have a look at an example that uses the shared data control. In this example, the graph that shows the department and the salary earned within is sitting in the region, exposed in the region on the parent view. And the parent view itself has a table that lists the detail information of the current selected department. So if I go to shippings, I click on the graph, this now will refresh the table, the detailed table that sits on the parent view. There's an example I wrote some time ago that uses contextual events for the same example, where there was a click event sent as a contextual event to the detail region. The detail region refreshed the table. Now in this case, it's using a shared data control. And when we talk about a shared data control, we're talking about a shared data control instance, which means that a parent setting on the parent collection has immediate impact to a detail collection, and that the detail, when it's, for instance, using ADF business components, which has an active model that makes sure that the master detail correlation is always synced up, that ensures that the detail actually matches the current selected parent entry. So let's click on the public relations node, and again it will query the detail table. So at design time, what we see is that we have this region here with a graph, and we have the table here. They both use the same data control, which I can show here. So this is reuse in the region, and it's used in the application. And the reason why the table refreshes has to do with partial page rendering. If I go to the bindings tab, then I see that the table as a dependent collection points to a collection which is the employees view 3 iterator, and on this iterator I'd set the change event policy to PPR. The change event policy, if you set this to PPR on the binding layer, what happens is that all components that are directly bound to that, not directly to the iterator, because it's using the tree binding, which you see here, the employees view 3 tree binding. This is used to populate the table, but the tree binding points to this employee view iterator, and because this sets to PPR, whenever the view iterator is getting refreshed, it will notify the tree binding about this event, and then the tree binding will refresh the table so that we can see the master detail behavior happening. The employees view 3 iterator is refreshed because of the strong relation it has to its parent, which is used in the region. The region uses the department's view 1 iterator, so when that changes, it will change the collection in employees view 3 iterator because they are sharing the same data control instance, and then this iterator will send a partial refresh to the tree binding, and the tree binding will make sure that we see the detail according to the selected graph bar in the parent view. If you wanted to deploy the region in an ADF library so you can reuse that, then of course you will have to make sure that you also deploy the application module that represents the data control so that you can reuse that as well, as otherwise you really need to have very good memory to remember exactly which collection you need to pick to have this master data dependency. But in many ways and in many cases, having a shared data control is exactly what you want, and it allows you to do an easy region to region or parent to region communication without setting up contextual events. The last communication interaction that we need to discuss is region to region, though we will see that region to region really is like reusing a couple of techniques that we already covered for the other communications. First of all, which is the one that always works, is contextual events, which is the superior implementation for region to region communication, as it allows you to directly call into a region without making too many assumptions and without having to share a data control or something like that. You could use drag and drop, as I showed, between the parent view and the region, but it can also be done between 2 regions, because drag and drop happened as an event on the client side in JavaScript, and the JavaScript doesn't know about region. One thing to keep in mind when you use drag and drop is you're making an assumption that there is a drop target in one region and a drag source in the other. But if that is fine with you, then this is a valid pattern for you to use. And again, shared data control can be used where you have dependent collections managed by a data control instance, and then you just need to figure out how to perform the partial refresh on the region to show the data synchronization depending on the selection of the parent collection. So this is what you have for region-to-region communication. Well, thank you. You've gone a very long way with me through discovering the region interaction patterns. As a summary, here is again the slide that lists all possible techniques and communication directions. First, we have the parent view to ADF region communication, which uses contextual events, can use queue action event, can use input parameters, and then perform a refresh of the whole region, in which case the bounded task flow is re-executed and rereads the input parameters. You can use a shared ADF data control instance, in which case dependent collections will behave in a master detailed fashion. You just need to partially refresh the region container itself, and you can use drag and drop. The asterisk, the stars actually remember you that there is, or remind you that there is a dependency that you create or an assumption you make. But again, though bounded task flow are made for reuse, if your decision is against reuse and you just want to use the bounded task flow and the region feature for convenient matters, or for being able to use a desktop pattern like the UI shell template, then that's fair enough. The other communication then is ADF region to parent view, again contextual events. Then you have a region navigation listener that informs the parent about any movement in the region, so that you can respond to that, whatever the response is. We have the parent action tag that you can use to navigate through a component activity or to an activity that tries to navigate the parent container or the root container, and if it fails, just still have a safe fallback to stay within the region, to continue the navigation within the region. Again, you can use a shared data control and drag and drop. And the last pattern is ADF region to ADF region. You can use contextual events, but you can also use the shared ADF data control or drag and drop. This is basically what works, and what you commonly, I think, will have a look at when you think about communication in regions. And as always, it's a matter of what is your use case that you want to implement. So there's no single best practice I can give. I can only point out that the more reuse you have in mind, the more likely it is that you use contextual events. And contextual events, of course, of its flexibility and also of its dynamic notion of broadcasting it or conditionally just broadcasting the message, will do a very good job in all of the cases that I'm introducing here. Alright, so at the end, just let me give you some pointers to where you can get more information. Of course, there's always the Oracle JDeveloper homepage, which is our central place where we link all the tutorials, how-tos, developer guides, and many more information around ADF and Oracle JDeveloper. There's the ADF Insider homepage, just in case that you got to this through recommendation or through Google searches. There's an ADF Insider homepage where we list all the videos that we take for basic and advanced conference style information that we want to share with you about ADF. And there's the ADF Code Corner website. The ADF Code Corner website is a very deep technical how to style block style page that provides you with samples, with documents that explain how features work, and possibly some of the samples I showed throughout this video will also end up at ADF Code Corner as an example for you to download. Of course, if there are books out there, developers typically feel better, and there are 3 books that we currently have in the ADF space. Starting from easy to more advanced, we have the Oracle Fusion Quick Start Guide, which is a 270 pages book that introduces ADF in JDeveloper to everyone who is really new to the technology, new to Java, or maybe coming from a 4GL background. Then followed up by the Oracle JDeveloper 11G Handbook, which is an end-to-end tutorial that really takes you from initial development gestures, taking you to how the IDE looks, how the IDE works, to going deep into IDF business components and helping you to build an example on the Fusion stack. This book may have the prerequisite that you have an understanding of Java, so it's not teaching you Java there. And then for the advanced users, the Oracle Fusion Developer Guide, which goes beyond the drag and drop capabilities that we have in Oracle ADF and that we promote in ADF, because where there's an easy, there always is kind of an advanced knowledge about the technology, And again, developers feel a lot better if they understand how they can tweak a framework, how they can work with a framework, how they can modify it and influence it, and how they can code against it. So just kind of looking underneath what's under the drag and drop functionality that we provide in Oracle ADF. Thank you very much for attending, and hope to see you soon back on ADF Insider.